Hi, this is Greg Koopman. In this video, I'm going to speak to you about a TSQL technique to help consolidate totals. Let's first talk about the problem. Totals from one report do not tie to another report, and you do not have a lot of the report code available to determine why. In other words, you're stuck. You've gone through all the rabbit holes to figure out why these two reports haven't matched. You don't have all the information. You didn't write both of the reports. And now you have very little more to go on except the difference between the two totals of the two reports. So what rows in your data set make up or add up to the discrepancy number between the reports? And how do you find that number? Or how do you find the rows that make up that number? There could be many different row sets that make up that number, or there could just be one or zero. But you need some mechanism to go through it, and the number of permutations you'd have to go through manually could be in the trillions. So that's kind of an impossibility. And this is where we come down to the solution. Write a program to find all the combinations of rows in the report data set that add up to the discrepancy total or totals of the reports. So what you need your computer for is to crunch those numbers by brute force, and that's what I'm going to show you, how to do that in the code to do it. Now, saying all here might be a little strong depending on how big your data set is. If it's very, very large, you can't let your computer just run for indefinitely for weeks or longer. So I'm using that word all a little bit loosely here. Okay, well, let's go ahead and get into the code. Here we have the code, and that runs the solution. And as you can see, it's all presented on one page, so I don't have to scroll down. So if you want to look at that code, that's how you can freeze frame it, and you can see the entire code for this demonstration. I'm going to break this apart as I describe the lines of code, and maybe use another window to query out a couple of things to make it more descriptive. So first of all, what we're going to do, you see I have some variables up here. You can create this as a stored proc or whatever you want to do, or however you use it. This is just a proof of concept here, more or less. And basically, I create some variables up here, and then we have a while loop. And within that, and the whole thing is a while loop, really. Okay, so it iterates through a number of iterations with a counter, and those iterations you can define here. So I'm defining 10,000. Let's break that down to 1,000. Okay, so I have 1,000 iterations I'm going to try to do, and I'm going to be looking for a target number, which is at 8196. Is the number I'm looking for. Let's say that's a difference between the two reports, and that's a number I can't understand why. Let's say I can't understand why there's a discrepancy of 8196, why there's a discrepancy, and why it's that number. So I want to see the row, any combination of rows that can add up to that number. Okay, I'm going to use a couple temp tables here. So since it iterates through it, I need to drop each of those temp tables during each iteration of the loop. So it drops table if exists in the name of the temp table. I begin the statement by using a with running total, and then this is where I use the AdventureWorks DW 2012 DBO. Okay, in fact, internet sales table. I'm using sales amount there. I have a unique ID as a primary key in that table. And then I run a top 100 rows, even though the table has 18,000 something rows. I'm going to copy that to another area here, and we're going to see what that looks like. So here, if I go top execute, right, you see the ID here. The ID starts at 1. So if I took out the top 100 and ran the whole thing, what you would see down in this corner, of course, is that there's 60,398 rows. If I ordered this by ID, by order ID, rather just ID, right? And I didn't run a sum. Well, I could leave the sum in there, but what it's going to do, you'll see ID goes all the way to 60,398, right? Okay, so that's how this works. So that's a little bit about the data. But now, I know that 8691, I think that's the number I was talking about, 8196 rather, is, you know, it's not going to take a lot of rows to add up to that. Looking at my numbers here, right? So most of my numbers are 4, 8, 49. You know, a lot of times, and some of these are even bigger. So it's not going to take probably at the most 10, maybe not even 10 to equal that 8169. So, but just to make it sure of it, I go ahead and I just say top 100, because I don't want to, if I don't need that many, I don't want to take that many. I don't want to take that many out of the table. Okay, so in this case, I'm only taking the top 100. This way, it iterates a little faster. But if you look at the numbers on the ID, well, that's not order. If we don't do an order by here, and we just look at that, you'll see these numbers as I hit execute. They keep changing, and you see some very big numbers, some small numbers. As you see, let's look at this a little closer. What I'm trying to say, the top 100 is going to look at that 68,000 and just give you the top, give you 100, give you 100 rows from that. Now, in this command, what you see is a Windows function called sum sales amount over order by new ID. Okay, and what that does is that automatically orders the table. It orders the table by new ID, and the sum will then, well, what it's doing is taking a running total. So 21 plus 98, 2198 is 2198, plus 2999 is 5197, plus 2294 is 2346, plus 999 is 23, as you get the idea there. Okay, so that's what this statement does, and the new ID is sorting this randomly each time. Okay, it's causing it to sort randomly. So let's go ahead and run this more, and as you see, it keeps the running total on that from there. So that's very important. So let's go back to our code. So that's our first thing. We stick that into a CTE, a running total. Then we place row numbers on it, and on there we go ahead and just say order by the running total, okay, and the row number, and give it a row number. Okay, so now when we run this, and then we place it into this place row number. So I'm running this from the CTE running totals. The running totals gives us the running total column, and then I run that from here. So let's just go ahead and take a look at that. So I'm going to copy that over to this other page. And we'll take out the into placeholder, and that runs it from the CTE. I guess this is a little bit harder to do, so let's we wrap the CTE, make that a CTE here like we do in the other code. Alright, so now it's going to run that, and it's going to give us row numbers. And the row numbers, so you see it gives us the row number here, and it's the row number is by the running total, ordered by the running total. Okay, and you see the regular ID, the primary key of the table, is still here. So as we keep running this, each time we run it, as you notice, all these numbers are changing. Of course, these go in the same order. Running totals change, although they're still ascending. And so sales amount and the rows that we're pulling back are always changing because of the new order by new ID. And I go through this order by new ID concept over in another video for sorting table randomly. So that's where this comes in. All right, so that's how that works. So as you see, now I'm just kind of building out on this in this code. I'm building as I go through it till I get to the final result I want. So now the next one I do is I say select into final results from placeholders. So I use what's in placeholders here, and I say I need the row number to be, okay, it's easier to look at this way. So if I say select the minimum row number from the placeholders number where running total equals 8196. So if I go back over to this result set, what I would be looking for is 8196. So as it goes through, if it finds that 8196, which this is not, but if it was, for example, it would say, give me the row number on all the rows before, and that would be what would come back. Okay, if it doesn't find that, the result set's going to be blank. Okay, it's going to be no rows. So that's what this whole thing does here. So it says select everything from final results, which was what we had over here, and go ahead and give me the row number where it's less than or equal to the minimum row number. And I say minimum row number because let's say there's 8.96 goes 4 times in a row. 4 rows in a row, okay? So there you just want the minimum one. So you go row number less than or equal to minimum row number from place row numbers where the running total equals that 8196. Now that 8196 really should just be set to this variable. So let me just put that in. Okay. So that's what that does. So what's that going to do is just instead of bringing us back the whole 100 rows, it's going to bring us back whatever the minimum row number is. Let's say it's 5. So it's going to bring us back 5 rows. Or if it doesn't find it, it's going to bring back no rows. Okay. So, and it's going to put it into this it's going to put it into this final results temp table. After we put it into the final results temp table, we then do an if statement that says if there's any rows in the final results table, then select everything from that final results ordered by row number. So in other words, this would bring us back in what I've been talking about, let's say 5 rows, okay? Because that's how many rows it comes to equal that target number variable, which is 8196 up here, okay? All right, so that's what that's going to do. So then I reset the counter. I set the counter to increment it by 1. I set a message that says counter equals. Then I cast the counter integer as a varchar 10, and that gives me a message. Then here I create, and you might not have ever used this before, but it's a very nice technique. I raise an error with no weight, which is kind of like printing a message. It's equivalent to just print message. Okay, it's not really any error going on here, but it's a backward way of displaying your messages. So you will be able to keep track. We'll be able to watch it go through all its iterations. Okay, and that's it. So then it goes back and while loops it all the way back to the number of iterations we set, which is 1,000 here. And each time it goes through an iteration and it calls that new ID, it gets a whole new sort of numbers, a whole new random set of numbers from that full result set, and then we chuck through it and look for that number, that 8196. And that's basically how the whole thing works. So let's go ahead and run this. And so you might go through 1,000 iterations and you might get nothing back. Or you might go by 1,000 iterations, you might get several back. Okay, it depends on what number you choose. The bigger the number, probably the more rows of data it's going to take to add up to it usually. So let's see what we get here. So I'm going to execute. And it's executing right now. But let's look at the messages. And notice the counter, that message, that no weight raise error, it's iterating through all these things. So already it's at like 400 almost. Let's see if there's any results. There's no results, right? So it's going through all these, basically it's going through all these permutations of ways to get to that number. So it's still going. Looks like we might not even have a hit. So, oh, well, there's one hit. Okay. And then we got, did it finish yet? It finished. Okay. So if we look down there, it went through 1,000 iterations. 1,001 iterations. And we got one result set. And the result set we got was running total 2198, 56. I'm sorry, with our sales amount was 21 plus 34, which is 56. 34 plus 24.99, which is 81.96. Okay, and that's how this thing works. So let's just go through more iterations, and let's see how many we get. We'll go through 10,000 instead of 1,000. Okay, so we're going to run it again, and I'm going to fast forward to it. So here's one already that came back, and see, this time it took 4, so it's 9.9953, and then here's your ID. Right, by having that ID, I can go right to those rows in the table and evaluate. Let's say there's different categories and different flags that were set, and maybe figure out why those numbers aren't coming into the results sets of the reports and why we're missing those. So this is what the whole point is. So that's why you want this extra ID here, so you can take these numbers and go back to the raw data set and analyze it and try to figure out which set is the right number, what rows, and why. So here's this row. This has come back with two sets of data, and as you see, it's different kinds of rows coming back, as you can see by the ID, and different values, right? Different values, but you can be assured that they're both being adding up to that 8196. Okay, so let's see. We go back to our messages, and we can pull down at the bottom. And we're down to 2,000 right now. So now this isn't to say that in the results sometimes you'll get a result set that is equal to one above it, but it depends. It just depends. So, and you're not going to know if it's going to be every single permutation possible. It's just, like I say, it's a kind of a brute force approach. The more iterations you give it in that variable at the top, if you make it 1 million, you might be spending. It's cycling through a lot of. It's probably using up a lot of CPU and a lot of resources. But anyways, if it could also take you weeks and weeks to figure out what number that is, or never figure it out. So this way you can at least see the rows it's evaluate that could be candidates for the answer to your problem, and that's why I wrote this program, and that's what it's used for. So if we wanted to change it, we could change it to, let's say, I don't know, I could say 59.98. I know that's going to hit. I could change it to 100.24 cents. I don't know where that's going to hit. I don't have those numbers in front of me, but hopefully your report difference it makes sense as far as this, where it can add up to that, or maybe it averages out to that, or maybe whatever your metric type of aggregation type, it's going to be average, sum, distinct, count, whatever it is. You can try to use some of this code and jury rig this code to make it work for you. Okay, so if we go back to our messages, we should see where are we at on this messages. So now we're at it's gone through 5,400, about 5,300 iterations, so it's halfway through. It's come back with 1, 2, 3, 4, 5, and then you just take this code and you can do different things with it. Of course, you probably want to insert it into another table so you can study it later. So anyways, that's what this code does, and I hope you have enjoyed this video. Let me just go ahead and show you the whole code so you can get a snapshot of that for your own use. So it's right here. There's an entire set of code right there. Okay, thank you for watching.